OpenAI did not just release one GPT 5.6 experience. It created a model lineup, Sol, Terra, and Luna. And if you're a developer, the worst thing you can do is use the strongest one for everything. That sounds backwards, but it is true. The future of AI development is not one model. It is model routing. Think of the lineup like a tool belt. Luna is for lightweight work. Terra is for daily productive work. Sol is for difficult work. The exact API pricing supports that tool belt idea. Sol is priced at $5 per million input tokens and $30 per million output tokens. Terra is $2.50 input and $15 output. Luna is $1 input and $6 output. OpenAI's Help Center describes Terra as the balance of capability, speed, and cost for everyday work, while Luna is the fastest and lowest cost model in the family. That is basically a routing map hidden inside the product lineup. That is the simplest way to think about it. Luna should handle tasks where the answer is low risk and easy to check. Summarizing logs, rewriting comments, drafting issue descriptions, generating title ideas, explaining a small code snippet. You do not need a frontier model for that. Terra is where normal development work may live. It can help with tests, simple features, module explanations, documentation, and small refactors. Sol should be reserved for tasks where a mistake is expensive, complex bugs, architecture decisions. Multi-file refactors, security analysis, agent workflows that run commands or edit files. That is the rule. Use the cheapest model that can safely do the job. Most developers will ignore this. They will use Sol because it feels premium. Then their workflow will become expensive. But professional AI usage will look more like infrastructure. Route the easy task to the cheap model. Route the medium task to the balanced model. Route the hard task to the strongest model. And route sensitive local experiments to local models when possible. For example, if you are building a feature, you might use Luna to clean up rough notes, Terra to draft a feature plan, Sol to inspect the repo and handle the hard implementation, then Luna again to summarize the pull request. That is smarter than sending every step to Sol. This also changes how teams should evaluate models. Do not ask, is Sol better than Terra? Of course, it probably is for hard tasks. Ask, which tasks can Terra do well enough? That question saves money. The same logic applies to Claude Fable 5. It may be excellent, but that does not mean it should answer every prompt. The winner in 2026 will not be the person with access to the strongest model. The winner will be the person with the best routing strategy, because AI is becoming less like a chatbot and more like a compute stack. Sol, Terra, Luna, Fable, local models, small fast models. Each one has a role. Developers who learn those roles will build faster and spend less. Developers who use the biggest model for everything will confuse power with productivity. Here is a simple way to apply this tomorrow. Create 3 prompt lanes. Lane 1 is quick work. This is for summaries, rewrites, titles, simple explanations, and formatting. The goal is speed. You should not care if the model is the smartest one available. You should care that it is cheap, fast, and good enough. Lane 2 is work mode. This is for normal coding help, documentation, test drafts, small feature planning, and content production. This is where a balanced model belongs. Lane 3 is deep work. This is for hard bugs, architecture, security, data loss risk, infrastructure, and agent workflows. This is where Sol or another top-tier model makes sense. Now add one rule. Every task must enter through a lane. Before prompting, ask, is this quick, work, or deep? That one question stops a lot of waste. For example, if you're asking for 20 title ideas, quick lane. If you're asking for a first draft of a script, work lane. If you are asking the model to reason through why a payment bug is happening, deep lane. The same system can work inside a product. Your app can offer fast mode, balanced mode, and deep mode. Users understand that. They already understand quality levels from video exports, cloud compute, and search tools. The developer mistake is hiding all of this and pretending every request deserves the most powerful model. That may feel simple, but it kills margins. The real GPT 5.6 lesson is economic. Intelligence is becoming something you allocate. You do not allocate maximum intelligence everywhere. You allocate it where the return is worth the cost. That is how developers should think about Sol, Terra, and Luna. Not as a ranking of ego, as a routing system for work. Here's the developer cheat sheet. Use Luna when the task is disposable. If the answer is bad, you can regenerate or ignore it. Title ideas, simple summaries, formatting, quick explanations. These are Luna tasks. Use Terra when the task is useful but not dangerous. Drafting tests, creating documentation, explaining modules, writing simple scripts, planning small features. These are Terra tasks. Use Sol when the task is hard or expensive to get wrong. Production bugs, architecture choices, multi-file edits, agent workflows, security analysis, performance investigations. These are Sol tasks. Now add Fable 5 to the picture. Use Fable when the task needs careful judgment, long reasoning, product thinking, or trade-off analysis. This gives you a 4-lane system: Luna for cheap speed, Terra for daily work, Soul for hard execution, Fable for careful reasoning. That is much more useful than arguing about which model is best. The best model is the one assigned to the right lane. If you build this habit now, every future model launch becomes easier to understand. You do not ask, "Is this new model amazing?" You ask, "Which lane does it improve?" That is how developers stay sane in the model explosion. There is one more detail developers should know. GPT-5.6 also adds more predictable prompt caching, including explicit cache breakpoints and a 30-minute minimum cache life. Cache writes are billed at 1.25 times the uncached input rate, while cache reads keep a 90% cached input discount. That matters for applications with repeated context, like coding agents that keep reading the same repo files. Smart caching can turn model choice into an architecture decision, not just a pricing decision.